Naples, Italy. 10 kilometers beneath the surface of the Earth, an intricate volcanic field works with each passing second, melting the surrounding rock and filling its magma chamber. Slowly, it's generating more and more pressure until it finally reaches its critical point, where it is then able to thrust itself upon the surface in a wave of destruction that could claim the lives of hundreds of millions of people, both in the surrounding site of the eruption and around the world, as the effects of what it is preparing to unleash spreads, disrupting climates, poisoning water and plants, and transforming rain into an acidic slurry of flesh-melting droplets. Campi Flegrei is regarded as one of the most complex volcanic structures in the world, with multiple lava chambers, numerous calderas, and 3 previous mega-eruptions that occurred within the past 40,000 years. People, both within Italy and around the world, fear it is due to repeat yet another gigantically destructive eruption. Recently, it has shown frequent activity that, within the past 3 decades, has steadily increased. Many scientists are worried it is close to a critical level, and that it might be very close to unleashing a wave of devastation unlike any modern humans have ever witnessed. So welcome to the story of Italy's supervolcano. Campi Flegrei, or in English, the Phlegrean Fields, are theorized to have been a major contributing factor to the extinction of the Neanderthal from Europe. Its first major documented eruption was between 37,000 to 39,000 years ago, give or take, coinciding with the date when Neanderthals began to vanish into the shadows of history. This is a 4-part series, with part 1 exploring the first of 3 previous mega-eruptions from this supervolcanic field. Part 2 and 3 will cover the other 2 mega-eruptions, and part 4 will focus on the present-day risk and aftermath of what would happen if it erupted at a scale similar to those seen in history in modern times. We're going to explore the facts and previous eruptions of this slumbering apocalyptic inferno in this video, and learn all that we know so far of the terrifying Campi Flegrei and the cataclysm it is waiting to unleash. History holds this area in high significance. It was known as the Burning Fields since antiquity, and was described as such both in Latin and Greek over 2,000 years ago. To the Romans, it was believed to be the entrance to Hades, god of the underworld in ancient Greek mythology, and is portrayed in such a way in an ancient Roman poem that has survived to present day, about a Trojan named Aeneas, who descended to hell through the gateway in a cave near Lake Avernus, a volcanic crater lake located within the Phlegrean Fields, which contained a cave known as Cocchio's Cave that connected ancient Romans to the Greek town of Cumae in ancient Italy, and was the world's first major road tunnel used for over 2,000 years. In modern times, this volcanic field holds the reputation of being one of the most complex volcanic structures in the entire world. But let's take a trip in time before the Romans, way before them, to a time in history known as the First Phlegraean period, one of the 3 geological periods we are going to explore. In the years between 37 to 39,000 BC, occurred an eruption with a volcanic explosivity index of 7, making this explosion a supervolcanic eruption, which starts at an index of 7, with the largest eruptions ever known on the planet going up to 8, such as Lake Toba and La Garita caldera. It is the largest volcanic eruption suffered in Europe in the past 200,000 years, and lasted between 2 and 4 days as one single non-stop explosive event. The eruption started when the magma of the chamber rose and came into contact with water, which triggered abrupt changes in the magma before it erupted 200 cubic kilometers of pure magma upon the surface of the Earth, and 500 cubic kilometers in total of rock, magma, ash, and toxic gases such as sulfur. The ash plume it released soared over 70 kilometers high into the air. After this initial eruption, the caldera collapsed upon the now rapidly emptying magma chamber, and a gigantic pyroclastic flow, fed by the magma in the upper layer of the magma chamber, flowed out of the collapsed caldera and covered an area of 30,000 square kilometers. Pyroclastic flows are the most dangerous aspect of a volcanic eruption. They are, by far, the deadliest characteristic of it. What happened in Pompeii, where the people who inhabited the town were immediately killed, only for their remains to be rediscovered and excavated hundreds of years later, with their final expression of anguish still remaining on their faces, were from pyroclastic flows. Its danger lies in how sudden it strikes. Imagine a boiling cloud of death surging at you at a speed between 100 to 700 kilometers per hour or 62 to 430 miles per hour, with a temperature of 1000 degrees Celsius or 1830 degrees Fahrenheit. To make matters worse, these flows touch the ground and either hurtle downhill or spread laterally under gravity. Outrunning it is impossible. This pyroclastic flow was immense and deadly. The flows that moved both north and south of the eruption overflowed over 1,000 metre high mountain ranges and crossed the Gulf of Naples over the sea, sterilising the land of all life within a 100-kilometre radius. This is probably one of the largest documented pyroclastic flows ever analysed by humans in history so far. The area around the eruption was completely buried, like Pompeii, by thick layers following the flows, which covered over 2/3 of Campania, which is this region in southern Italy. It covered it in 100 metres of thick volcanic debris, rock, ash and other volcanic fallout. Ignimbrite is a grey rock released by volcanic eruptions during pyroclastic flows, which is basically a variety of hardened tuff. Tuff meaning a light, porous rock formed by the consolidation of volcanic ash. It is formed when thick layers of material are left following pyroclastic flows, which, if are still at a sufficiently high temperature, actually welds the tuff into this type of rock, occurring generally in temperatures exceeding 500 degrees Celsius. This is important due to the next fact. After this eruption, enough ignimbrite was deposited to cover an area of at least 7,000 square kilometres of land, mostly encompassing the southern Italian peninsula and eastern Mediterranean region, with calculations conducted at over 110 different sites, giving a number of over 300 cubic kilometres of tephra released. Tephra is basically material left over after a pyroclastic flow that was not hot enough to be welded into ignimbrite. This tephra covered an area of 3,700,000 kilometres squared. All up, the total bulk volume of the first Phlegraian period was close to 700 cubic kilometres of fallout, covering most of the eastern Mediterranean with ash clouds reaching as far as central Russia. Following this eruption, temperatures dipped, climates suffered, rain poured upon the earth as acid rains from the sulfur dioxide released from this mega-eruption. The fluorine-laden particles that rained upon the earth became incorporated into plant matter, causing serious eye, lung, tooth and organ damage upon the animal populations alive during that time. Let's quickly put this eruption into perspective to better understand its devastation. The most deadly volcanic eruption humans in recent history have ever known was the 1815 eruption of Mount Tambora, which, like this, was also a volcanic explosivity index of 7, but was over 4 times weaker in comparison, releasing over 100 cubic kilometres of debris, but killed more people than any other volcano humans have ever been unfortunate enough to have encountered in the past 5,000 years. With a death toll of over 71,000 people, with many more thousands dying from starvation, Mount Tambora caused the notorious year without a summer, which caused widespread famine, crop failure, and starvation due to the eruption's effects on the climate from the amount of debris it released, which blocked the sun's ability to heat the earth by a significant amount. Imagine now how this eruption, which was over 4 times weaker than the first Phlegraian period, would have affected the world and the people living in it. The final decline of Neanderthal populations in Europe, which were replaced by Homo sapiens, occurred around a period of this eruption. The Neanderthals were already significantly declining prior to the eruption, but the climatic effect, the rapid cooling of the Earth, and the additional environmental stress placed upon them from it is thought to have been a major factor for their inevitable extinction. Traces of magma from it can be detected all the way in Greenland upon observation of its ice cores. It is very possible this eruption caused the inevitable end of the Neanderthals, which cleared the way for modern humans to thrive in Europe and Asia. This eruption created the 13-kilometre wide caldera that in present day is observable only 20 kilometres west of Mount Vesuvius. The two actually have a common magma chamber, roughly 10 kilometres beneath the Earth. So, this is the story of the first known mega-eruption of the Phlegraian Fields, and a testament to why the Greeks and Romans referred to it as the Burning Fields. Welcome to part 2 of Campi Flegrei, the second Phlegraean eruptions. In this episode, we're going to learn the facts of the second Phlegraean eruption, so let's get started. After the cataclysm unleashed upon the Earth between the years of 37 and 39,000 BC, Campi Flegrei wasted no time in rebuilding its massive interconnected magma chambers to release another earth-shattering eruption upon Europe. Only 2,000 years would pass before it would make its reappearance upon the surface, in a time period so short it's almost unheard of for mega-eruption-sized volcanoes, all of which normally take tens of thousands to hundreds of thousands of years to recharge their gigantic magma chambers. Campi Flegrei, however, is a rare beast that is incredibly skilled in the art of destruction. Between the vast time periods ranging from 35,000 to 10,500 years ago, the Phlegraean fields, time and time again, would resemble a hellfire, erupting in a huge manner, though luckily these eruptions were all at a smaller scale than the previous single super eruption we covered in part 1. All of these, however, dwarfed the normal eruptions we are used to from your typical stratovolcano, and was still in the range of a volcanic explosivity index of 7, ranging from an eruption that was at the minimum either equivalent in scale to Mount Tambora or just slightly under it, and at a maximum just under the mega eruption during the first Phlegraean period. The majority of these eruptions are still visible today in the many calderas observable around Naples in Italy, which becomes especially obvious when looking at it through satellite imagery. However, Campi Flegrei is deceiving in many ways. 15,000 years ago, Campi Flegrei changed its strategy, which culminated in the most devastating eruption within the time period of the second Phlegraean period. In the past few thousand years, it worked at extending its magma chamber by widening its width, which led to it striking in a seemingly more innocuous and silent place, seemingly being the key word, until it decided to blow. This time period within the second Phlegraean period is referred to as the Neapolitan yellow tuff eruptions. Yellow tuff is a soft rock of volcanic ash that was a very popular item for construction since ancient times. It's amazing to think the yellow tuff of this eruption was used in the construction of the Roman Empire, and in a moment you'll see why. Just off the coast of the present-day town of Pozzuoli, this volcano decided to give the animals and humans alive that inhabited the area a new surprise, in the form of a new disaster to deal with, alongside its gigantic eruptions: mega-tsunamis. You see, volcanic eruptions are generally less impactful in regards to tsunami generation compared to, say, a very large earthquake. But this rule only applies if it occurs in very deep water, such as what is found in the Pacific Ocean, and is why there aren't many noteworthy tsunamis of volcanic origin from there that occurred directly because of the eruption. Landslides and other means of displacing water during a volcanic eruption are a disaster in itself, but in this situation I'm referring solely to the magnitude of the eruption causing the displacement of water, and only that, with a comparison to something like a bomb being detonated underwater. The reason tsunamis of volcanic origin aren't powerful if they are generated in deep water is because the dispersal is so huge that it can't concentrate on one area, and the energy from the eruption gets scattered immensely, producing short-period waves. However, eruptions that occur in shallow areas are a completely different scenario. The differing length to depth ratio of the waves rapidly increase, and the run-up inland can be unimaginably high, which leaves the closest bit of land to the eruption in this situation vulnerable to suffering from gigantic waves that could reach a height over 50 to 100 meters or more, depending on where it erupts and the intensity of the eruption. There have been many noteworthy tsunamis that were generated directly from volcanic eruptions in history, but a more recent illustration of this was the KARYMSKY lake eruption in Russia, which, in a relatively small lake of just over 2 kilometers, a 19-meter high tsunami was produced as a result of the volcano erupting. With a normal volcano, a mega tsunami is not likely to occur. However, with a supervolcano, it definitely can if it is located in shallow enough water. The Neapolitan yellow tuff eruption occurred in the shallow bay off the coast of Pozzuoli, and to this day is the largest known aquatic eruption ever studied. When magma reacts with water, the type of eruption produced differs from the more typical eruption most people have in mind when they think of volcanoes. By that, I mean the ones that occur with overpressurization due to an accumulation of gases that are released when surrounding rock in the magma chamber is melted, which, in the process of this, releases volatile gases that are directly responsible for the increases in pressure within the chamber. Rock is melted into magma, it releases explosive gases, Pressure as a result of this rises within the chamber, and this pattern steadily repeats until it reaches a critical level where it finally triggers a release through eruption. There are a few different types of volcanic eruptions, but I'm only going to mention the two that relate to this scenario. Normally what comes to mind in the aforementioned circumstances is a type of eruption which is named a Plinian eruption. These are the large volcanoes such as the one that devastated Pompeii or the eruption of Mount St. Helens in America. The underwater eruption of Campi Flegrei occurred as a result of new magma reacted to being exposed to seawater rapidly, which is a type of eruption referred to as phreatomagmatic eruptions, in which both magmatic gases and steam from water are expelled. Now, I've got to quickly get into a little of the science of this to allow you to appreciate and imagine the scale of just how giant and devastating this eruption would have been, and how a tsunami could be created from it, as well as how a wave generated as a result of this would have been a towering mega-tsunami so high it is truly terrifying to imagine. The exact nature of how volcanoes erupt from a phreatomagmatic eruption is still a cause of debate that has been narrowed down to two possible situations, or a combination of the two. They are either driven by thermal contraction, which is the complete opposite to the volcanic eruptions, such as the one I described during a Plinian eruption, which are driven by thermal expansion. Thermal expansion occurs when you heat a material and it gains more internal energy, such as a supervolcano heating and then melting more and more rock, adding to its thick gelatinous chamber of magma, which builds more pressure and explosive energy in the form of the gases released from melting the rock that allows the chamber to gain more internal energy. The atoms within the materials move around faster and the material expands, or in this case, the magma chamber expands, and that's why we see a swelling of the ground before supervolcanoes erupt, which we have seen in the case of Campi Flegrei in recent times, but I'll cover that more in part 4. Until, like a balloon, the supervolcano reaches a critical level, overpressurizes and explodes, causing an eruption triggered by the thermal expansion. Thermal contraction occurs when you cool the material down, and the atoms don't have that much energy. So to apply this onto the scenario being described, it basically means the magma suddenly changes shape, area, and volume in response to a change in temperature, such as water contacting magma in a very sudden manner. The massive temperature difference between the magma and the cool water causes very violent interactions that make up the eruption. You can see this for yourself if you heat up a pan and then put cold water onto the pan once it's very hot. This tiny little explosion is basically a replica of what would have happened during this situation. The second way that is debated is called fuel-coolant reactions, which are speculated to be more critical to the incredibly explosive nature rather than just solely thermal contraction. However, it could also be from both of these combined rather than from only one or the other. A fuel-coolant reaction is just basically a steam explosion, which is an explosion created by the immediate and violent boiling of water into steam when it is superheated rapidly, which seems to explain why these types of eruptions are so violent. Personally, I think it's a combination of both of these that make large-scale aquatic or groundwater-based eruptions so violent. Okay, that's the science out of the way. Now, let's get into the fun stuff. A supervolcano and a 100-meter high wave, which is 328 feet, with a lip of 191 meters or 640 feet. A lip is the expression used to explain the top of the wave that curls forward. If this was the scenario, it would have been so terrifying it'll make your skin crawl before it crushes you with the incredible weight that is equivalent to 2,183 brown elephants that weigh 6 tons each, or 874 Tyrannosaurus rexes that weigh 15 tons each. This wave has a total weight of 13,120 tons. Ouch. This is just a quick example of how heavy the wave would have been if it was this big. The reality is it could have been way bigger or a little bit smaller, but either way it was still gigantic. This eruption, due to it being underwater, has very conservative estimates being attributed to it. Some scientists suggest it was larger than 100 cubic kilometers in size, which is proving to be true more and more every day as more studies are conducted on it. Conservative estimates place the number, at the very least, within the range of 40 cubic kilometers of volcanic debris released that covered an area of at least 1,000 kilometers squared around its epicenter. The problem with attempting to study an ancient underwater supervolcanic eruption, aside from the obvious inaccessibility and inability to study like you normally would on land, is also the fact that the ocean, far more than the land, is in constant flux, washing debris into the deeper recesses or pushing it on land before sucking it back in and sending it to some faraway place for it to finally come to a rest. There are, however, some facts that are well established. This is most definitely the largest phreatomagmatic eruption ever known to man. It also generated the second largest pyroclastic deposit ever known. only coming second to the first super eruption covered in our last episode. The pyroclastic flows occurred underwater, which is both incredible and baffling to attempt to imagine, and the resulting sediment raised the seafloor where it erupted, making it even more shallow than it previously was. When this volcano blew, fallout was ejected up to 34 kilometers from the vent, which is incredible when you understand this happened underwater. The scale of explosivity for this distance to have been reached would have been enormous. This is where things get dangerous, however. In a similar, albeit lesser effective fashion to tsunamis induced by earthquakes, during the eruption, just like the previous one, the magma chamber collapsed upon itself as it was emptying. So this is a two-pronged effect. An earthquake generates a tsunami due to the sudden displacement of a large quantity of water, such as when a tectonic plate slips downwards against the plate it is pressing against, which causes a massive amount of water to also slip down with it, only to rebound back up, producing a deadly tsunami in the process. This gigantic underwater supervolcano collapsed upon itself during its massive eruption. This not only displaced the water by a large area of land suddenly collapsing upon itself, but also by the gigantic eruption that led to the chamber emptying to the point of collapse. So in this situation, there are two catalysts that produce a series of tsunamis, not just one. And to top it off, it's in shallow water. This is more than enough reason for the generation of a mega-tsunami. So, off the coast of Pozzuoli, a massive eruption occurs underwater. Within a few minutes, Pozzuoli, Naples, Sorrento, and the 3 neighbouring islands are consumed by a gigantic wave that swept inland for kilometres. When it finally recedes and when the eruption is finally over, what is left aside from the complete sterilisation of all life on the surrounding lands is a ridiculous amount of yellow tuff, just waiting to be mined and used by the Romans and Neolithic humans thousands of years later. And that was the last major eruption of the second Phlegraean period. It ushered in the third Phlegraean period. This final eruption was responsible for the formation of the caldera that encompasses the modern-day town of Pozzuoli, which sits inside the caldera, and it transpired during the time when the Younger Dryas Ice Age event suddenly descended upon the Earth, which before it was heating up. The cause of this is unknown and is still being researched to this day to find out what sequence of events caused this ice age. A recent gigantic meteorite crater in Greenland was found underneath the ice sheets, which may have coincided with this period. But the finding is very recent and needs to be studied further for an accurate idea of the situations that led up to its formation, as well as what was produced after it and when it was produced. The reason I am mentioning this is because one scary thought I've had is that if it did strike the Earth around this time, the shockwaves produced would have been enormous and might have actually caused Campi Flegrei to erupt. Just like we covered in our video on the North Korean supervolcano and what happened to the magma chamber when Kim Jong-un detonated nuclear bombs near it, which sent powerful pressure waves towards Paektu Mountain and the giant magma chamber contained within it, with that pressure then being transferred to the magma inside. If this meteorite struck and the pressure from it caused this supervolcano to erupt, that would have been a truly grim time to have been alive. Welcome to part 3 of our 4-part series on Campi Flegrei, Italy's supervolcano. In this episode we are moving forward and looking at the third and final Phlegraean period. This period of Campi Flegrei's volcanic eruptions occurred between the years of 10,000 BC onwards, and it itself is split into 3 epochs of eruptive activity. I just wanted to quickly reiterate that each time Mount Vesuvius has erupted in history, such as the time Pompeii was completely destroyed, was also an act of Campi Flegrei, as the two actually share a magma chamber. So this actually skews with the dates if you include the two, which most scientists do not, preferring rather to focus on one or the other as though they are single entities. However, the two are one thriving system of complete and utter destruction. The third Phlegraean period is marked by the release of a very characteristic volcanic ash that separates it from the yellow tuff released during the second Phlegraean period and the ignimbrite of the first Phlegraean period. This volcanic ash is called pozzolana and is a white-coloured volcanic ash. To point out what you most likely have already noticed, scientists are relying on the characteristic debris released from each major eruption, which has allowed the split into these 3 differing Phlegraean periods, more so than any rigorous dating of the existing calderas. Another key fact I wanted to point out, these are the mega eruptions that are known, and scientists speculate many more have occurred during these time periods that may have been concealed almost entirely by the mega eruptions that followed them. Regardless, the most concise way possible to humans in present day is the labelling and dating of the now solidified materials that were ejected during the eruptions, which has been key in helping to split the eras of these eruptions into the three distinct periods that we in modern day refer to as the first, second, and third Phlegraean periods. The first epoch of the third Phlegraean period, 10,000 to 7,500 BC. Shortly after the mega eruption and mega tsunami unleashed at the end of the second Phlegraean period, Campi Flegrei was back at unleashing its trademark devastation upon the region, again altering its strategy and this time erupting more frequently than ever witnessed in the two prior Phlegraean periods. In the time span between 2,500 years, there occurred roughly 34 explosive eruptions with a mean frequency of one eruption every 70 years. Which means if there was a human during this point in time lucky enough to live to the age of 80, they could have possibly witnessed one violent eruption per generation. Or if they lived to the age of 40, obviously one eruption every 2 generations. These eruptions were horribly explosive and varied from magmatic to the more volatile and arguably more destructive phreatomagmatic eruptions, which, to reiterate, is when magma makes sudden contact with water, which is a process that creates a dangerously violent explosive reaction. The nature of these eruptions were dependent upon the position of the vent and whether or not it was on solid land, the coastline, or just off the coast of Pozzuoli. The caldera itself at this time was on average 60 meters lower than present day, with the major part of the caldera depression overcome by the sea. Only the northern sector remained above sea level continuously. The second epoch, 6,600 BC to 6,210 BC. The second epoch started with a bang, pun intended, with the eruption of the Fondi di Baia in the western sector, which roughly occurred around a date of 6,600 BC. In this epoch, 6 low-magnitude explosive eruptions with a mean frequency of 1 every 65 years erupted along the northeastern sector of the Neapolitan yellow tuff caldera, which was created by the mega-eruption that ended the second Phlegraean period. Finally, after these 6 eruptions passed, the poor, battered landscape of Naples found itself in a short period of peace, with no eruptions occurring for approximately 3,500 years. Underneath the ground, however, Campi Flegrei was working hard and slowly refilling its magma chambers, and was transferring some of its glory to Mount Vesuvius, which in another 2,080 years would awaken to bury Pompeii. During this period of partial peace, the sea level rose once more, causing erosion to the many calderas Campi Flegrei created around Pozzuoli. The third epoch, 2,700 BC to 1,700 BC. Around the time of 2,700 BC, Campi Flegrei emerged once more with 16 explosive eruptions and amazingly with 4 effusive eruptions, which is something Campi Flegrei is not known for. Effusive eruptions are eruptions similar to those in Hawaii, which is the gentle oozing of magma when it reaches the surface due to hot, runny, molten basalt, which due to its consistency allows gases to escape easily. In previous eruptions, these gases would normally be trapped within the magma, and this is key to the explosivity of a volcano. The consistency of magma has a direct influence on the destructiveness of an eruption. Plinian eruptions and supervolcanoes, which are actually Plinian eruptions but fall under the category of ultra-Plinian, have very dense and thick magma. The thickness of the magma within these types of volcanoes traps in the volatile gases, leading to significant pressure increases within the chamber that eventually blow the entire landscape above it when the pressure reaches a critically unsustainable level. Volcanic eruptions like those in Hawaii are effusive eruptions and have magma that is a very runny consistency which fails to trap in the gases that would otherwise lead to gigantic eruptions. As a result, these types of eruptions are barely an eruption. Rather, they slowly ooze forth onto the surface and creep their way across the land until the temperature finally cools, leading to the solidification of the lava. The The aforementioned explosive and effusive eruptions occurred with a mean frequency of 1 every 50 years, with the majority of eruptive activity located around the northeastern sector of the Neapolitan yellow tuff caldera, with the exception of 2, which occurred in a northwestern sector in the area where the later 1538 AD eruption transpired. It was during this third epoch that Lake Avernus was created from the caldera left over after one of these 16 eruptions occurred. The 1538 AD eruption. The 1538 eruption of Campi Flegrei, although weaker than its counterparts, was still amazing and very notable in history. This eruption created a new mountain before the very eyes of the people alive during that time, and was aptly named Monte Nuovo, or New Mountain when translated to English. For 8 days straight, starting on the 29th of September 1538, an eruption began building the 123 metre or 400 foot Monte Nuovo. This eruption ended a long 1400-year period of uplift, when new areas of land formerly occupied by the sea emerged, and was noted by the residents of Pozzuoli in 1502. This uplift was due to the magma chamber underneath swelling as pressure that eventually led to the 1538 AD eruption steadily increased. From the early 1530s, unusual seismicity that reached a first climax in the spring of 1534 occurred, with more earthquakes regularly occurring. That, with the benefit of hindsight, was actually serving as a forewarning for the eruption to come, with the quakes dramatically increasing around September of 1538 prior to the eruption. On the 28th of September 1538, roughly 20 tremors were felt between daybreak and nightfall. These tremors were actually the magma itself, forcibly pushing its way towards the surface. This is where things get quite amazing. In an area between Lake Avernus, Mount Barbaro, and the coast occurred an incredible uplift of the earth, which actually displaced the coast by several hundred meters. An uplift of 7 meters occurred overnight, in the night preceding the 1538 eruption. This means the ground rose an amazing 23 feet in the span of only 12 hours. This is not an exaggeration and has actually been witnessed in modern times. The 1994 eruption in Rabaul, Papua New Guinea saw the ground doing the same incredibly rapid uplift, rising over 6 meters or 19.5 feet the night before the eruption occurred. And so, following the 1538 AD eruption, we shift into the brief respite that has occurred for close to 500 years up to present day, with a brief moment of volcanic activity occurring in the early 2000s, which will be covered in the 4th and final episode to conclude this series. In part 4, we will be covering modern day Campi Flegrei and what would happen if it erupted on a scale similar to the one unleashed during the first Phlegreian period. Alongside this, we will also finally explain what it is exactly that makes Campi Flegrei so dangerous and why this particular volcanic complex is remarkably technical and unique compared to the others found on our planet. Welcome to the 4th and final episode in our series on Campi Flegrei, Italy's notorious supervolcano. We have taken a detailed journey through the sands of time and uncovered every known step of Campi Flegrei's history, from its first cataclysmic mega-eruption during the first Phlegreian period 40,000 years ago to the gigantic series of mega-tsunamis generated by the eruption that ended the second Phlegreian period roughly 12,000 years ago. Then we continued forward to uncover the alarming frequency that made up the eruptions of the third Phlegreian period, which saw us journeying from 8000 BC all the way up until the 1538 AD eruption. The links for all 3 prior episodes can be found down below in the description. In this video, our level of detail drastically increases as we explore the events that would occur if Campi Flegrei erupted in modern times. Only with a twist. We're going to be using the most destructive supervolcanic eruption known to man as a reference point for Campi Flegrei's explosivity index. This means that Campi Flegrei in this analysis will be erupting at a VEI 8. The reason for this point of reference is to not only explore the devastation Campi Flegrei would unleash in this scenario, but will also illustrate the worldwide effects of an incredibly powerful supervolcanic eruption by exploring what the world and humanity would look like following the scenario. We will also be covering exactly how and why Campi Flegrei is so incredibly different and unique compared to any other volcano and supervolcanic complex in the entire world, both extinct and active, and how the ground above it is acting as a stronger than normal prison for modern Campi Flegrei's magma chamber that in the most unique circumstances renders the earth above it stronger than normal by an amazing extent, which has, up until today, confined its eruption. Then we're going to dive right into present day and a simulation of a mega eruption. I felt that a long video format was required for this final episode in order to do this incredible supervolcano justice. I hope you understand. For those of you who aren't a major fan of longer format videos, I have broken down the video into parts with links to each topic I'll be covering posted in the description box below. Feel free to skip ahead to parts that interest you most. Please leave a comment letting me know if you like these longer format videos, or if you prefer shorter ones, or a bit of both, so I can factor that into future videos. To start, I'll be quickly covering some very important final questions, as well as one new discovery made this year at Campi Flegrei. So I hate to indulge in the I told you so type of behaviour, but I told you so. Funnily enough, during the time I was writing this script, which I started during the end of April this year, a conclusive result on a 29,000-year-old giant eruption has been documented, revealed, and finally listed as an accepted fact in scientific literature. This eruption was another giant one that spread a volcanic ash layer that covered more than 150,000 square kilometers within the epicenter of the eruption. The name given to this eruption is the Massaria del Monte TUFF. How did this giant eruption hide from the eyes and minds of scientists that have been studying this complex for decades? The results indicate that this eruption of Campi Flegrei was similar in scale to the Neapolitan yellow tuff caldera, which was created at the end of the second Phlegreian period. The following statement reiterates what I have said in past episodes about the fact that trying to pinpoint every single eruption that has occurred at Campi Flegrei is near impossible because of the fact that any large eruption that follows it has a very good chance of completely concealing its existence by covering it up completely. So I quote, "The lack of thick, traceable deposits for this eruption appeared to be the result of the eruption dynamics and their destruction and burial by more recent activities. This research highlights the benefits of investigating explosive eruption records, preserved as ashfall in sedimentary records, when attempting to accurately reconstruct the tempo and magnitude of past activity at highly productive volcanoes such as Campi Flegrei." In the last episode, I clarified the fact that many historic Campi Flegrei eruptions, both small and large, have been hidden by the subsequent eruptions that occurred after them. Meaning there are many more eruptions that have occurred at Campi Flegrei than we can accurately assess, and this is going back over 300,000 years ago and possibly even further back in time. Many websites, including those of notable scientific research institutions, state that Campi Flegrei has erupted in the times we have conclusively covered in our series, but alongside that has also erupted during times as far back as 315,000 years ago, 205,000 years ago, 157,000 years ago, and also a peculiar one at 18,000 years ago. And this has been concluded by argon dating. But like we assumed, this complex system is very difficult to gain answers conclusive enough to be listed within acceptable scientific literature. Now, there's an amazingly unique set of circumstances regarding the composition of the terrain above the present-day magma chamber of Campi Flegrei, and it is actually actively working to restrict an eruption from occurring. Take for example this scientific abstract by the London Geological Society that was published in 2006 after fears of an imminent eruption by Campi Flegrei that were rising steadily past the stage of alarming to uh-oh, it's gonna blow, as the seismicity in the region increased to abnormal amounts. In the last 4 decades, Campi Flegrei's caldera has been the world's most active caldera, characterized by intense unrest episodes involving huge ground deformation and seismicity, but at the time of writing has not culminated in an eruption. The results show for the first time in a volcano that a very peculiar mechanism is generating episodes of unrest, involving mainly activation of the geothermal system from deeper magma reservoirs. The character and evolution of unrest episodes is strongly controlled by structural features, like the ring fault system at the borders of the caldera collapse. 13 years after this abstract was written, the ground has still kept in this beast that is working so hard to be freed from its earthen shackles. Any other volcano on Earth would have erupted by now from the hundreds of earthquakes that have occurred at this site. So what makes this complex different? Well, Campi Flegrei actually created its own prison. That may sound weird, but I'm not joking. If you remember in our last episode, we mentioned pozzolana was the characteristic type of rock that was released during the eruptions of the Third Phlegraean period. This was used by the Roman Empire, who mined it directly from pozzuoli. Roman concrete is infamous for being stronger and more durable than modern day concrete, and it was made from pozzolana. The Romans figured out if they added lime to pozzolana, the resulting mixture formed a ridiculously durable type of cement that was used to construct buildings, roads, the Roman Colosseum, the Pantheon, and even the construction of several harbours throughout many different countries within the Mediterranean region. The Romans can't take credit for this anymore though. Campi Flegrei was doing this thousands of years before the empire even formed. Deep within the caldera of Campi Flegrei, rocks that contain lime, which have become liquefied under the magma chamber's severe heat, actively reacted with the pozzolana sitting above the magma chamber, which was released during the Third Phlegraean period that saw a tremendous amount of pozzolana being spewed upon the surface of the Earth, leading to a vast accumulation occurring above the magma chamber itself and all around it in the nearby landscape. This is quite amazing. Campi Flegrei has literally cemented its own magma chamber, forming a powerful concrete prison that has become an immensely powerful cap rock, able to withstand much larger earthquakes and deformations in comparison to the typical rock makeup found around any other volcano on Earth. This could explain why there hasn't been a large eruption since the pozzolana began to be released during the Third Phlegraean period. The downside to this, of course, is the amount of magma that is accumulating as a result of not being able to depressurize through frequent eruptions, means the next major eruption could actually surpass the eruptive size witnessed in all previous eruptions known to man. And this is another reason why in the following scenario, I wanted to do an analysis of Campi Flegrei erupting at a volcanic explosivity index of 8. So this answers why it hasn't yet erupted, even with the ever-increasing frequency and power of earthquakes in the past few decades. This also may be why Mount Vesuvius has erupted at levels that have been increasingly dangerous and devastating, with the two sharing a common magma chamber. The eruptive phases could be following the path of least resistance. So, without further ado, let's continue our journey from 1538 to the simulation of a modern-day Campi Flegrei eruption. After this eruption, I'm going to finally answer why Campi Flegrei is so powerful and erupts in a time span so frequent, especially compared to other supervolcanoes. 2009, the solfataras roar as the eruption draws near. A solfatara is a vent that emits sulfur. It is also frequently referred to as fumaroles. The Solfatara di Pozzuoli is the most famous vent. It actually erupted in 1198 AD, which I didn't cover in the previous episode due to the fact it was a measly volcanic explosivity index of 1, and I wanted to sum up both past and modern day Solfatara di Pozzuoli in the same episode, as it was a very minor phreatic eruption with very little noteworthy info on the topic. This solfatara formed 4,000 years ago during the Third Phlegraean period, and its vapours have been used for medicinal purposes since Roman times. The name comes from the Latin solfa terra, which means land of sulphur or sulphur earth. Who would have thought smelling rotten eggs could be construed as medicinal? The Pisciarelli is another solfatara that was once considered insignificant. In 2009, Pisciarelli began attracting attention. Its activity suddenly drastically increased. It was a hint that something very bad and very dangerous was occurring below the ground. The land within Campi Flegrei's caldera had been rising for nearly a decade, and in 2012 it began to rise at a more rapid pace. From January 2012 to June 2013, the ground rapidly uplifted about 11 centimeters or 4 inches, with a peak rate of about 3 centimeters or 1 inch per month during 2012. In 2006, a paper in Nature Communication suggested a new dangerous phase may have been entered by Campi Flegrei. From 1950 until the aforementioned date, the ground had swollen by more than 4 meters. Scientists predict the caldera floor will lose its elasticity at between 5 and 12.5 meters of uplift, during which the ground will be unable to withstand the exerted force, which would lead to an eruption. In 2017, activity became so high that an eruption was feared. A magnitude 4 earthquake on the western edge of the caldera occurred, killing 2 people and injuring many more people in Casamicciola on the northern coast of the island of Ischia, which is south of the epicenter. In this same year, another study was released by UCL and the Vesuvius Observatory that was published in Nature Communications and revealed an eruption might be closer than previously thought. Now is the time we will uncover the power of a supervolcano as Campi Flegrei erupts at a VEI 8. So let's move into the simulation of events leading into its modern day eruption and what occurs following it. The eruption of Campi Flegrei. The day shall turn to night, and Europe, then the entire world, will bear witness to Campi Flegrei's power. In the months prior to the eruption, earthquakes become ever frequent and increasingly more powerful than ever experienced in prior centuries. They occur without periods of rest, with an ever-increasing scale and frequency. Panic begins to generate as news reports and scientists predict the eruption of this volcanic complex is nearer than ever before. Others remain in a blissful state of ignorance and dismiss these claims, having heard it so many times, and they continue with their day-to-day lives, whilst the most cautious pack up their belongings and move their family as far away as they can travel. Most of these people will think they are safe, but unfortunately many of these people will not have travelled far enough to escape the eruption. The day before the eruption, hundreds of earthquakes are generated. Hiding from the naked eye beneath the ground, the magma is breaking apart the pozzolana that's kept it in for so long, and it rips the very earth above it as it surges upwards towards the surface. As nightfall approaches, the people and animals attempt to sleep while the earth shakes below them. Anxiety is at its highest as the locals are used to earthquakes, but this phenomenon is something completely different to the norm. Many of these people think maybe the reports of an imminent eruption were right, and that becomes a statement that echoes in the minds of thousands of people during their final night on this earth. In the early morning, an earthquake of a tremendous scale shakes the earth violently. Buildings crumble from the power exerted. People attempt to flee outside for safety. Suddenly, a flash of light so bright it blinds anyone who witnesses it occurs. Accompanying this flash is a sound so loud it bursts eardrums immediately. This is all that the people and animals within the epicenter will hear and see before they are immediately vaporized. This happens at a speed so fast that recognition of what is taking place cannot be mustered before life is literally snuffed out. The ground explodes at a force never seen or even imagined by a human. As the contents of the magma chamber blow out onto the surface, the very ground many people once called home collapses upon itself. In the Bay of Naples, gigantic tsunamis are generated both from the eruptive power and subsequent collapse of the caldera. The reaction of the enormous amount of magma that has now made contact with water within the bay produces immensely powerful phreatomagmatic reactions that further expand the power of the eruption. Pyroclastic flows travel in all directions, smothering and destroying everything in its path outside of the newly formed caldera. A gigantic column of ash surges high into the sky, reaching well over 80 kilometers in height or more than 50 miles. Lava bombs, which are a mass of molten rock, are sent in all directions, with some of them being as large as a car and others even larger. The sound of the explosion begins its journey around the world. The sound waves will circulate the entire globe multiple times over. People further than 500 kilometers or 310 miles away have their eardrums ruptured, and the sound of the eruption is heard by people as far away as China or in the opposite direction as far as New York, possibly even further. Scorching ash burns anything it makes contact with as it falls back down upon the earth, and a massive cloud of ash begins a long journey to share the destruction with the entire globe. The sun on this day never rises in Italy, and the surrounding countries soon suffer that same fate. This phenomenon will continue for a good while. Italy is no longer recognizable. The entire surrounding landscape is completely sterilized, transformed, and covered with ash, pyroclastic flows, and debris fallout. Rome is completely wiped off the map, and the Colosseum is no more. The pozzolana used to create it has been returned to its maker. Gigantic tsunamis destroy all surrounding lands. Sardinia, Corsica, Sicily, and Italy's northern coast become submerged by water. Malta and the Balearic Islands soon join the destruction. The coastlines of France, Spain, Morocco, Algeria, Tunisia, and Libya all get hit by towering waves that swallow up as much land as it can. To a lesser extent, though still by a destructive amount, Greece, Albania, Turkey, Cyprus, Egypt, Syria, Lebanon, and Israel get hit by secondary waves produced after the main wave bounced off Sardinia, Tunisia, and Sicily. First Italy, then the world. The column of ash created by Campi Flegrei can be seen by countries all around the Mediterranean. A feeling of dread overcomes those that witness it rise into the sky. A supervolcano is so powerful it bends the rules and conventions. It doesn't need to follow the planetary winds. It creates its own on account of how powerful the eruption is. The ash spreads out in a circular motion to all nearby territory until it loses enough power to then finally become directed by planetary winds. The air becomes smothered by the initial ash cloud before it finally loses enough power to begin to follow the direction of the wind and spread to the rest of the Earth. Over 5,000 cubic kilometers worth of debris is released from this eruption, which is enough to bury the entirety of Italy a few times over. As the eruptive force that was generated weakens, it begins to follow a northeasterly direction, being carried by the planetary winds. From the island of Crete all the way to Germany, the noxious, sun-smothering cloud of death begins its worldwide journey, and we're going to follow along with it as it spreads further and further east, following a path that is now predictable as it is carried by the consistent planetary winds. Stage 1. The ash cloud journeys over to Russia, smothering all lands it comes across as it makes its journey towards it. It proceeds to darken the entire gigantic territory of Russia, after which its journey takes it over the North Pacific and Bering Sea. Portions of the now scattering thick ash cloud get caught in a northeasterly trade winds. This splits the thick cloud apart, sending it in two directions. The first directs a large part of the thick, noxious cloud over the Bering Sea and northernmost part of the Pacific Ocean, where it would then cross over into Alaska, Canada, and almost all of the United States, minus the most southern states, as well as Greenland and Iceland. It would then continue over the North Atlantic, covering the remainder of Europe from the topmost point down to Campi Flegrei's original epicenter. Stage 2. The second direction, separated by the northeasterly trade winds, would direct a very large portion of this ash cloud towards Japan, then China, the Philippines, the northern point of Indonesia, and all of Malaysia and the surrounding countries. Upon hitting India, the cloud would scatter in yet another two directions. The first portion would continue its journey along its already pre-directed path, and would overcome the Middle East and the northern portion of Africa, where it would then travel over the mid-Atlantic before shrouding that seemingly free southernmost part of the United States, as well as all of Mexico, the Caribbean, and the northernmost tip of South America. Stage 3. The other direction that was split when floating over India would be forcibly directed south of it over the Indian Ocean, before it got caught up in the southeasterly trade winds, which would then direct this noxious cloud over towards the southern portion of Africa, from the middle of it all the way to the southernmost tip of it, after which it will travel over the southern Atlantic Ocean towards the interior of South America, where it would then split yet again. Stage 4. The first portion would continue over the southern Pacific Ocean towards New Zealand, Australia, and the remaining territories of Indonesia, Papua New Guinea, and all surrounding islands. The other direction that would be taken is directed south towards Antarctica, which would eventually shroud Tasmania all the way through to the remaining southern tip of South America. The world is now completely shrouded by the toxic blanket of Campi Flegrei's gigantic explosion, and the sun loses its power as the Earth begins to cool. One day after the eruption of Campi Flegrei, the isolation begins. Immediately, the repercussions of this ash cloud become very evident as it spreads across Europe, then the world. Humans, for at least 3 generations, have faced a world that has shrunk noticeably in the way we've perceived the distance of countries and cultures since the invention of the plane, car, and even more so since the internet made its way onto the scene. One by one, countries consumed by the impending ash cloud come to a stall. Air travel is no longer a possibility in these locations due to the abrasion suffered by forward-facing surfaces upon contact with volcanic ash. This means the windshield, leading edges of the wings, and ash accumulation within surface openings, including the engine of the aircraft, causes damage to the compressor fan blades, eroding the sharp blades in the process and reducing their efficiency. Upon entering the aircraft's combustion chamber, the ash changes form by melting and becoming like molten glass. Solidification on turbine blades follows. This blocks airflow and causes the engine to stall, causing a complete loss of engine thrust. Planes literally begin to drop out of the air, and unintended chaotic contact with the ground comes next. The detection of ash clouds is near impossible aboard aircraft as there is no onboard instrument to detect them. On the ground in airports, visibility is reduced significantly, making landing near impossible. Not only that, the accumulation of ash causes incredibly slippery runways and taxiways. The ash causes further damage to communication and electrical systems at airports, as well as interrupting ground services and damaging buildings and parked aircraft. Basically, anything electronic the ash makes contact with has a good chance of failing. Fast trade by air travel has suddenly become a thing of the past. Emergencies must be dealt with fewer hands than has been seen in over a century since trade by modern vehicles became a reality. The world suddenly seems so much larger. 2 days after the eruption. Fresh air. Oh, how I miss you. It might not come as a surprise to many that breathing in volcanic ash is pretty bad for you. In fact, it's very, very bad. Some people may think it would be no different from breathing in smoke from a large fire, but it is markedly different. The particles in volcanic ash are very hard and have jagged edges. This not only damages the eyes and nose of people and animals who breathe it in, as well as irritating the lungs, but causes severe problems with breathing, as well as physical tears inside the tissues of lungs. Don't forget, after all, volcanic ash can essentially be likened to a non-smouldering version of solidified lava on a tiny scale. It's basically like tiny shards of frozen magma. It's composed of silicon compounds, the same as the sand on your favorite beaches. It is created at such a rapid pace during an eruption that it actually becomes glass, with each individual fragment consistent at a length that is at a maximum no longer than 2 millimeters across, with the majority of it being so tiny it is directly inhaled and shuttled internally to organs you probably don't want tiny shards of glass to be in. Supervolcanic eruptions are incredibly high in silica. In fact, the level of silica reaches at least 75% in the overall composition within the magma versus the normal 25 to 50%, which makes the magma so stiff it acts like toothpaste, and this directly influences how destructive eruptions are due to increasing magma viscosity. The ash is lacerating the insides of your capillaries, bronchioles, and alveoli. As you can probably imagine, the process of this isn't exactly pain-free. If you are lucky enough to survive, in the long term you could suffer from silicosis, which results from permanent scarring to your lungs. But to be a bit graphic, the corneas on your eyes will also get worn down, and your eyes will start to bleed if exposed to the ash for a prolonged enough time for the many corrosive substances to do their damage. And, well, if you're near Campi Flegrei, or in a place close to the initial ash cloud spread, with no way of getting indoors, death is likely to occur through just plain old suffocation. If the barrage of silica isn't enough to get you scared, then the hydrogen fluoride is enough to get you really pushing up daisies. Well, that is if those daisies could survive the impending volcanic assault, which they can't and won't, so they'll join you in your inevitable fate. Hydrogen fluoride is rapidly absorbed into the nose and into the upper respiratory tract. Severe eye irritation, mucous membrane damage, ulcers, burning of the skin, nose, throat, and lungs occurs at just a tiny amount of exposure. For example, it takes only 5 parts per million for a decline in lung function at rest and increased airway resistance. At 6 parts per million, irritation of the eyes, nose, and throat occur, and at 10 parts per million, the irritation worsens to almost unbearable levels. Between 10 to 15 parts per million, the threshold of toxicity for prolonged exposure occurs, and at 20 parts per million and over, paralysis and death occurs after extended exposure. Unfortunately, at 150 parts per million, a healthy individual can expect to survive for only a few minutes before he or she succumbs to a very painful and suffocating fate. And the amount released by a supervolcano would far exceed this in certain places, especially those near the eruption. And you thought the silica was bad, you've got these 2 horrific compounds to deal with, as well as the rest of the toxic cocktail released from Campi Flegrei's eruption. 3 days after the eruption. humanity grinds to a halt. The eruption of Campi Flegrei has already caused massive disruptions in many various ways that has in turn caused massive complications to humanity. Fatalities have been suffered, a toll of which has risen to a point that is physically uncountable. Traversing the land itself is a task arduous enough to now be thought of as near impossible. Disruption over roads, railways, ports and shipping yards has taken a toll already after only 3 days. Staying outside whilst the toxic plume of demise that is seeking to extinguish all life is impossible without proper equipment. A gas mask, safety goggles and full body protection from head to toe becomes a necessity to survive outdoors. As ash piles accumulate increasingly on houses and large buildings, these structures collapse under the incredible weight, as those seeking reprieve from the toxic ash cloud within these structures succumb to a fatal fate. Visibility is reduced to within only a foot or two in front of you. Driving is not only extremely difficult, but is incredibly dangerous. Cars that travel more than 50 km per hour or 31 miles per hour stir up the settled ash on the ground, making these toxic particles airborne once more. Accumulation of ash creates a dangerous decrease of traction, only exacerbated during wet conditions. Road markings and the road itself is completely covered, and suddenly the thought of whether or not you are actually even driving on a road anymore becomes a question pondered frequently. But this won't be a problem for long, because after a few more days, cars stop working altogether. The air and oil filters become completely blocked, and replacement is required after only a short time of travel henceforth. 4 days after the eruption, agriculture becomes a distant memory. Volcanic regions on Earth are known for producing some of the best soil to grow crops and plants in. But that's after many years pass, when the soil is allowed to drain of any toxicity and to achieve an equilibrium of pH and mineral content that is contaminant free. However, unfortunately, this rule doesn't apply during active volcanic eruptions, or honestly would be completely fine to survive any eruption that doesn't directly affect us during the initial stages. Unfortunately, agriculture is destined to suffer a violent fate following Campi Flegrei's major eruption. Ash withers and kills all crops within a week or two through various mechanisms. The first direct mechanism is the fact that volcanic ash contains chemicals toxic to plants, some of which are actually essential for their life in very minuscule amounts, such as sulfur, but in high amounts burn and kill the plant very quickly. You can see this firsthand if you spray a high amount of fertilizer on a plant, especially if you do so undiluted. It scorches them to death very quickly. The worst killer by far, however, would be the deadly levels of fluorine found in volcanic ash, which not only kill all plants, animals, bugs, and even microbial life found under the soil which work in unison with plants in a shared partnership of mutual benefits, but also contaminates the very soil itself. And it only gets worse. Thick ash falls that exceed 15 centimeters or 6 inches or more buries the pastures and the soil beneath it. This is how microbial death occurs due to oxygen deprivation, as well as any plant alive that is now covered by it, which also meets a rapid end by burial. Trees accumulate ash on branches which break under the weight. Orchids meet a slower fate in comparison to crops such as corn, soy, rice, and etc. But the high levels of fluorine, sulfur, silica, as well as the other chemicals and minerals that in moderate amounts are toxic, reach a level far beyond moderate, and upon contacting plant life, enters it by two means. It gets taken up by the root system of trees and plants, leading to an inevitable death. But even more deadly than this process is the act of foliar absorption. This is a major absorption pathway plants use, and through it they're going to absorb these poisons that in the end leads to a much quicker fatality by the organism than it would if only being taken up by the root system, which is a process that is much slower. It absorbs far more of the aforementioned toxic compounds in a quicker time span than through the roots. Foliar absorption is when the leaves of the plant take in nutrients. The leaves of a plant are much like the skin human beings have. It has the ability to absorb many different compounds. Fungi such as mushrooms, which rely on oxygen in the same manner humans rely on it, cease growing as their mycelial networks die from oxygen starvation. If the toxic slurry produced by the ash cloud doesn't kill the most resilient trees, unfortunately the ability of ash to trap water would eventually waterlog the roots, leading to root rot. If, by the slimmest of chances, a plant manages to survive the aforementioned amount of numerous deadly assaults cast upon it, the acid rain that falls steadily not only burns the plant but also affects the pH level of the soil, raising the acidity of it to unbearable levels, killing off the remainder of seemingly resilient life that was scarce in number to begin with, weeks after the eruption. Alongside the deadly pH swing is the reduction in the amount of phosphate and other minerals in the soil, increasing the difficulty for growth and survival. Some areas of the globe will have a devastating loss of life in all categories. Every part of the globe will be affected, but some may be lucky in the level of dispersal and fallout, especially if yearly rain is heavy and consistent, such as what is experienced in tropical regions of the planet, which might have some hope in survival due to the eventual washing out of ash and the acidic minerals and elements left over by it. If there was a tremendously consistent amount of rain falling, it is going to wash these out much quicker. 5 days after the eruption, the food chain loses its links. With the contamination of the ground, livestock perish by the hundreds of thousands to millions very quickly. Grazing animals get gastrointestinal blockages from consuming ash-covered grass, leading to death. As little as 1 millimeter of ash-covered grass can kill grazing animals. If there are no other sources of feed, starvation is also a factor. With the decline and death of grain-based agriculture, feed will become scarce. It will rise dramatically in price too. Wildlife also suffers. They fall prey to a horrible fate from the consumption of contaminated food and water sources. This includes carnivores that, upon preying on the weakened grazing herbivores that are unable to flee or fight due to their weakened state, become poisoned from the contaminated food source. Obviously, this also means humans are unable to consume poisoned livestock. This is because the toxic fluorine accumulates primarily in the skeletal tissues of terrestrial animals. This leaches into edible tissues and even the milk of mammalian fauna. This means no more cows, milk, and no more cheese. Uncontaminated food becomes a near impossible task to obtain and becomes ever fleeting as time passes. The food chain becomes horribly disrupted and ceases to be a chain. 6 days after the eruption. Traversing the sea during a volcanic apocalypse. Trucks, cars, planes, trains, and every other manner of transportation for essential goods that are now more than ever required by the European countries that were first hit by the subsequent effects of Campi Flegrei's eruption becomes a distant memory. For many countries, hope is beyond fleeting. Even if there were unaffected countries that weren't doing so bad and able to trade, as soon as they enter territories that are overcome by Campi Flegrei's ash cloud, they will be unable to traverse and their equipment and mode of transportation will fail. Where there is a gist of hope, however, at this stage, lies solely within freight ships that attempt perilous journeys, making their way to the affected countries in an attempt to deliver vital goods. Food, medicine, fresh water, and much more is required by so many nations. The supply is scarce as more and more countries and entire territories become freshly enveloped by the spreading ash cloud. Fear is at an all-time high all over the world. Unfortunately, the freight ships never make it. Ash accumulates and blocks air and oil filters. It abrades moving parts within the engine. Vesiculated ash, which is pumice and scoria, float on the surface of the ocean waves as the ship gets closer and closer to Europe. These are light volcanic rocks, formed by the quick solidification of glassy lava, and they present another horrific danger. They clog the water intakes of ships. The machinery that it relies on then begins to overheat until irreparable damage and failure occurs. Navigation becomes an almost impossible task because of the thick smog, and the people aboard it rely on their instruments to get to their destination. The ship comes to a halt, and without sails to navigate like vessels in ancient times, they are unable to continue moving to their destination. And so they now sit bobbing up and down in the middle of the North Atlantic Ocean, rocking from side to side. The people on board praying to find salvation, perhaps by other humans, or by floating to an area of dry land, which in the end won't offer much safety. The much needed supplies go to waste as it never accomplishes its goal. Acid rain falls night and day. Navigation is impossible, and unless land is within a foot of your eyes, the hope of seeing it will never happen. The acid rain eventually eats through the hull of the ship, alongside every other surface exposed to it. Water begins to enter, and within 24 hours, it and its passengers become one with the bottom of the ocean. No help is coming. 7 days after the eruption, things seem to be getting a bit fishy. Many humans forced to undergo the above events would probably begin to turn their attention towards seafood. And for a good reason. Surely this would be a better source of food with a lesser chance of contamination, right? And even if contamination was present, surely the levels of it would be below fatal. Well, it depends. The fish that live within inland water sources are totally unfit for consumption, as their water sources become poisoned, and those in the ocean, though affected to a lesser degree, become a deadly game of will I live or die when I eat this fish, due to the fact that going out some distance into the ocean to fish with a boat is now an impossible task as previously mentioned. And even if you had a ship with sails, if you are unlucky enough to have acid rain falling while you're in the middle of the ocean, it's going to eat through them immediately. I mean, acid rain eats through stone, metal, paint. It even eats through marble statues and renders their once elegantly carved features unrecognizable. This means fish very close to the shores would be the only option, and right near the shore is where the highest level of oceanic contamination would occur, through the many rivers and drains containing contaminated water flowing out into the ocean, causing widespread contamination at the shorelines. However, due to the increasing desperation of circumstances, that may be a game many of us would be willing to play. I'm yet to mention the major impact that oceans will succumb to, and I will cover that very soon. It deserves a category of its own. Unfortunately, it's not only food that gets contaminated. Something far more important to all life on the planet also succumbs to its share of deadly contamination. 8 days after the eruption. Fresh water becomes death water. All reservoirs, rivers, lakes, creeks, and any other source of potentially fresh potable water quickly becomes contaminated, both from direct contact with ashfall and the fact that with each and every rainfall, water that contacts contaminated soil gets washed downstream, resulting in it eventually flowing into a body of water at some stage of its journey to the lowest ground, whether that be a creek, lake, or large river. But it's not only the above ground water that faces a problem, it's also the groundwater itself that humans utilize, which is vital in many places as the only source of water, such as many islands and any desert that has an oasis that the people who live there rely on to live. These sources of once potable water become rapidly overcome by toxic hydrogen fluoride. It also transforms much like the ground does from a stable pH to a deadly and possibly fatal acidic beverage. Humans and animals begin to succumb to starvation and to their thirst, meeting a horribly fatal conclusion. The only way to drink fresh water in severely affected parts of the earth is through filtration, which is beginning to become a scarce commodity and which becomes blocked in a very short time after use. 9 days after the eruption. The rain, it burns. Is there no cleansing to this hellfire? Hydrogen fluoride and hydrogen chloride are both compounds that become outgassed into the atmosphere, where they are then dissolved in water droplets. Once these two compounds are introduced to water vapour, they become hydrofluoric and hydrochloric acids that eventually fall towards the Earth's surface as acid rain. Hydrogen chloride is equally as harmful. It irritates mucous membranes of both the respiratory system and the eyes. A concentration of more than 35 parts per million results in throat irritation, and exposure to more than 100 parts per million causes pulmonary edema and laryngeal spasms. It is also the direct factor to the aforementioned lowering of soil pH. Another lesser constituent of volcanic eruptions is bromine oxide, which breaks down the ozone when released into the stratosphere. It breaks it apart by taking a molecule of oxygen from it. This chemically converts ozone gas into oxygen. In 2010, a relatively mild eruption in Iceland, which rated as a 4 on the Volcanic Explosivity Index, resulted in the destruction of 84% of the surrounding ozone in only the first hour of the eruption, with 90% destroyed in 6 hours preceding this. Now imagine that compared to a supervolcanic eruption with a Volcanic Explosivity Index of 8. 10 days after the eruption. Nothing works. Hope has faded. Telecommunication and broadcast networks become a thing of the past. Signal strength had slowly been waning due to damage, alongside the overloading of the network through user demand. Direct ashfall damages telecommunication equipment, which require constant cooling via air conditioning units, which have since become blocked by ashfall until they are no longer able to function. Cable lines, aerials, antennae dishes, and towers collapse due to the accumulation and overwhelming weight of ash loading. Moist ash acts to accelerate corrosion of metal components in areas that have received rainfall. Computers lose functionality and usability, but do not completely fail unless they are directly exposed to ash. Moist ash can cause an electrical short in desktop computers, but won't affect laptops in the same manner. However, all computers, both desktop and laptop, lose total functionality through the following scenario. The lights no longer operate. The volcanic ash has taken its toll on the electrical power supply systems at all levels of power generation, transformation, transmission, and distribution. First, wet deposits of ash on high voltage insulators initiate a leakage current that inevitably leads to a short circuit current high enough to trip the circuit breaker. Ash-induced flashover, which is the unintended electrical discharge around or over the surface of an insulating material, burns and cracks the insulation to a state that is irreparable. This occurs on a grand scale. The volcanic ash then erodes and scours all exposed metallic apparatuses, affecting moving parts to the largest degree. Everything from water and wind turbines to the cooling fans that keep transformers and thermal power plants functioning ceases to operate. The physical weight of the ash itself causes line breakage and damages the steel towers and wooden poles that transmit the power across the grid. Mankind is thrust centuries back in time and rely on a candle to offer a meagre amount of light to extinguish yet a tiny amount of the never-ending darkness. Water no longer travels through the pipes that once supplied the first affected countries, and soon the rest of the severely affected countries around the world will follow. Water stations, such as large water treatment plants, become subject to interference due to airborne ash affecting the operation of wellhead pumps. The electrical outages also contribute by disrupting the many electrically powered pumps. If there are backup generators, they run on a very scarce time limit before they consume their reserves. Ash further affects treatment plants by blocking intake structures, causing severe damage to pump and impellers, as well as overloading the pump motors. To top things off, waterborne diseases become increasingly frequent, as the suspended particles from the ash that have fallen into the water provides an excellent substrate for microorganisms, which flourish and reproduce at an alarmingly increased rate. This process can actually serve to protect them from disinfection treatment. On small water treatment plants, ash quickly clogs intake structures, damages pumps, and blocks pipes. Disinfection becomes close to impossible, as does upkeep and repair. They are left to decay in time as humans become a sight no longer seen at these places. 11 days after the eruption. Disease outbreak reaches a pandemic. Emergency services cease. Wastewater treatment facilities and wastewater networks would sustain similar damage to what causes the aforementioned water supply networks to begin to fail. Ash enters the sewerage system and backs it up, causing double the impact on countries which rely on systems with a combined stormwater and sewage lines. Ash-laden sewage entering the treatment plant finally brings down the mechanical pre-screening equipment. It then penetrates further into the system before settling and reducing the capacity of biological reactors, as well as increasing the volume of sludge and even changing its composition. It becomes a bacterial haven, and they begin to multiply at alarming rates. Emergency services are no longer available. Everyone is left to their own fate now, including them. Phones don't work, vehicles don't drive, hospitals no longer operate after power ceases to become available. Medicine is in very scarce supply as more and more people get sick from contaminated water. The backup of sewage that contains harmful bacteria, fungi, parasites and viruses cause numerous ailments ranging from infections of the lungs, intestines and gastroenteritis, which spreads amongst humans at an alarming rate as E. coli, typhoid fever, salmonella and cholera join the assault on humanity. Whenever it rains heavily, sewage overflows onto the streets and near former treatment plants and even flows into water reserves that are contaminated already from the volcanic ash, which, like previously mentioned, causes these organisms to flourish even more. Many of these water sources, though contaminated, are still being used by desperate people suffering from severe thirst. This only acts to further proliferate the spread of these types of harmful organisms. 12 days after the eruption. Desperation spreads. Chaos is in full swing, and a complete breakdown of society occurs in the heavily hit countries. Citizens arm themselves and take to the streets, robbing and looting anything of conceivable value. Violence becomes a new way of life, and participation in horrible, unfathomable things that have now become a common reality occur. First world countries become reduced to primitive tribal conflict, as some survivors form gangs and fight for the remaining scraps of food and water, while others, heavily armed and knowledgeable, take what they can alone, in pairs, or in small groups. They are all doing whatever it takes to survive. Fires spread throughout the cities, only barely illuminating the seemingly eternal darkness. The smoke from it thickens the already substantial dark smog that has trapped people within its choking grasp since the eruption occurred. People go from house to house, taking what they need, using violence to get their way. The weak fall victim to the strong, and the fabric of society has been undone. Humanity will never again be the same if it lives to see it through this seemingly never-ending apocalypse. Day 17. The nuclear contribution. 7 days after the power grid ceased, nuclear power plants that have now been abandoned while still in operation begin to explode, in a fashion similar to the meltdown of Chernobyl, from overheating reactor cores. Normally, automated protocols would shut down the reactor completely and autonomously, but this is dependent on the mainline and backup power being present. There are two ways this situation could proceed. Hopefully, humans have the foresight to cool reactor cores down immediately following Campi Flegrei's eruption, and work to prevent a subsequent nuclear contamination, adding yet another unbearable element to this already overwhelming disaster. However, since the power grid failed 10 days after the eruption, whether or not humans would still be present at these facilities is questionable, and for those countries that thought they could withstand what was coming or who substantially rely on nuclear power, this may not be an option in the mind of the person who decides the outcome to this critical situation. By the time he or she realizes that they were wrong and that their reactors needed to be shut down immediately, physically getting to the nuclear power plants may already be an impossible task. Many European countries rely on nuclear power, and if these plants exploded, the level of cataclysmic destruction jumps up to unbelievable levels. Radiation joins the fray and spreads to unfathomable distances across the globe. Chernobyl spread all around Europe and even reached America. The aftermath. The weeks and months following the Campi Flegrei eruption. In the weeks and months since the eruption of Campi Flegrei, famines, disease outbreaks, violence from a breakdown of society, and many more factors have led to the end of an uncountable amount of life. Hundreds of millions to billions of people met their end from Campi Flegrei. To those still alive, sickness is further proliferated from the decaying remnants of those that have succumbed to their fate, that are now rotting in the very same place where they drew their last staggered breath. The cold is unbearable. The challenges produced by Campi Flegrei's eruption seem to never end, and continue to echo in the months and even years following the dreadful event. The notorious volcanic winter is now in full swing, as the injected sulfur gases within the stratosphere undergo a series of reactions to create sulfuric acid, which nucleates and forms aerosols that cool the surface of the Earth by reflecting the much needed solar radiation as well as absorbing terrestrial radiation, which in unison lower the climate by a number of degrees below the norm. This produces catastrophic results, especially in the temperate climates around the Earth. In Europe, any attempt within the next few years to grow and sustain a harvest of crops would be near impossible, as crop failure is far more likely to occur, as below normal temperatures in unison with unpredictable weather hamper any form of establishing a potential comeback through agriculture. With no heating, hypothermia is a very real threat. The environment rapidly changes, resembling more of an ice age. Continental glaciations occur, further reducing plant, animal, and human life, even more than what has already occurred. Life becomes increasingly difficult. This volcanic winter will last at the very least over a decade, and the weather will take many more years, perhaps even decades beyond that, to fully stabilise. The final impact. Finally, we reach the final effect of Campi Flegrei's wrath. The disrupted climate through the injection of sulfur has another effect other than the dreaded volcanic winter. Huge volcanoes directly reduce the mean sea temperature, as well as obviously the land temperature. This lasts for many years and could last for multiple decades beyond the eruption. In part 2 of the Campi Flegrei series, we mentioned and explained the process of thermal expansion and contraction. This process affects everything, including the seawater itself and the variability of its level. Thus, with decreased heat content, the result on the global sea level actually reduces it below the normal point. But it happens in a strange order. Firstly, the sea level actually increases as a direct response to major volcanic eruptions, and the subsequent climatic effects that occur due to it. This is because after a volcanic eruption, the subsequent blocking of solar radiation from entering and the lowering of exiting terrestrial radiation sees the rate of evaporation of the ocean reducing by a significant amount. Thus, the rains that follow fill up water levels, raising them in height until the process of evaporation begins to reach a new equilibrium, more on par with the shift in temperature. After 1 or 2 years, river discharge becomes less due to the reduced precipitation and reduction of sea ice melting. The sea levels drop as a result. The positives. Yes, there are some positives in an otherwise dark situation. The first is the sunsets look freaking amazing due to the sulfur aerosols that were released. But on a more relevant note, humanity would most likely survive. Less affected areas may be able to pull themselves through this situation. But those who are self-sufficient and those who are lucky enough to live in tropical regions would likely make it through this horrific situation if they are dynamic enough. Modern humans have lost the survival instinct that our ancestors relied on, so hopefully they'll be able to get this back quickly, because they're going to need it. Alongside this, the drop in temperature in tropical regions wouldn't be quite as significant and devastating as what will be suffered by Europe and any temperate climates, including southern Australia. And it's likely that even with the decrease in solar radiation, some food sources can still be grown and utilised effectively, as there are many plants that can be grown with low light, lettuce being an example among many. Humans may also survive the climatic effects felt in temperate regions. After all, humans have proven themselves time and time again to be able to survive unimaginable difficulty. We are a very resilient creature, and with the amount of humans scattered in every part of the world, it is unlikely that this event will be the nail in humanity's coffin. Unless we get really unlucky and some kind of massive meteorite decides to join the destruction and slam into the earth, then we'd probably be toast. So with that, let's get on to the big question. Why is Campi Flegrei so damn powerful? Even an eruption at a scale seen during the first Phlegreian period would be enough to render most of Europe and many other surrounding and distant territories around the world plunged into a state of complete chaos, and would follow the same series of events we just covered. Alongside this, the temperature around the entire globe will be affected. This volcanic complex erupts so powerfully at a rate unheard of. So what's causing this? The answer? The collision of 3 tectonic plates. In this situation, we have 2 major and 1 microplate colliding. The first major plate is the Eurasian plate, which is moving in a southeasterly direction. The second is the African plate, which is slamming into the Eurasian plate as it forcefully pushes north. Now, caught in between these 2 gigantic plates is the Adriatic microplate, also known as the Apulian microplate. Between these 3 plates is the weakness within the Earth, where magma is able to rise, both from the planet's core and from the friction and rock melting heat produced by the collision and subduction of the nearby tectonic plates, as well as many fractures and places of instability along these points, causing an even greater weak point. This weakness not only allows greater than usual magma to rise, but generates more magma than what would otherwise occur through the strange directions attempting to be achieved, and the resulting collision and subduction as a result of this. Thus, we have the reason for the creation and existence of the Campanian volcanic arc, which begins around Rome with a few dormant volcanoes and continues to Mount Etna in Sicily, and even further down all the way to the Campi Flegrei ma Sicilia, which is a field of submarine volcanoes located southwest of Sicily. All of these derive their power from the same place within the Earth. The only thing separating them is the differing degrees of weakness within this area of major collision. So this is what leads to the terrible reputation that is held by many Italian volcanoes. Etna in Sicily is considered the second most active volcano on the planet, only being beaten by Hawaii's volcanoes. Vesuvius is probably one of the most notorious and well-known city-destroying volcanoes, and Campi Flegrei is the terrifying beast that hides near it. A depression within the ground created from eruptions so destructive, the exact amount of debris released, and the amount of eruptions that have occurred might never be conclusively known. And so, with that, we reach the end of our long journey into Campi Flegrei's history, legacy, and possible future outcome. When Campi Flegrei will finally break through its concrete prison isn't known. It could be tomorrow, next week, or next year. One thing is certain, when it does ascend, Europe won't be the same place ever again. Thank you for watching. I'll see you all in our next video.